So welcome to the episode about Shropshire's Cambrian rocks. Today's episode is going to be a bit of a short one, as there's not a lot of Cambrian exposure within the county. However, here at the Ercall quarry, it's one of the best places you'll find Cambrian rocks anywhere in the county. You'll find a number of exposure at the hamlet of Comley on the side of the hill Caradoc. Now at Comley, they found some of the first microfossils anywhere within the Cambrian period within the UK, so the site does have special significance. However, the exposures are rather overgrown and you can't really see a lot. Plus, because it's a site of special scientific interest, you're not allowed to fossil hunt there. So really what you're only able to do is just take pictures and look. So behind me, what you can see is two different coloured rocks. You've got a pinky orange colour, which is the Ercall granopyra, which is an intrusive igneous formation. And this is actually from the late Precambrian, from the Ediacaran period. The white grey rock sitting on top of it is what we're here to see, and that's the Cambrian sandstones. In this case in particular, it's called the Ercall quartzite. Now, it is an actual sandstone, it's not a quartzite. Quartzite is a metamorphic rock. It's one of those cases in science where we've got an old term that got labelled and it's just carried on being used as such, similar to the Stiperstones quartzite that we saw in the Ordovician episode. So let's get up close and personal to this rock. So what we've got behind me is an unconformity that's found at the Ercall quarry. Now, it's one of the best places to find unconformity anywhere in the county of Shropshire. There are a few other places, but this is the best place where one is exposed. Now, an unconformity is a break in the rock sequence. So what we've got is the pink-orange Ercall granopyra, which is from the late Precambrian Ediacaran period, which is around about 600 million years old, something like that. And that sits unconformably underneath the Ercall quartzite. So what we've got is a gap in the sequence of about 40-50 million years where we've got this discontinuity within the rock sequence. So we've got this volcanic intrusion, and then on top of that we've got the sedimentary sandstones of the Ercall quartzite. So what causes an unconformity? Multiple reasons. Two of the big ones being that either the rock layer was never laid down in the first place because the environment was not depositional, and or it's because those layers that were laid down were eroded away. So what you get is a gap in the sequence between the deposits of the rock. So you end up with a non-continuous environment, and that's what gives you your unconformity. So what is the Ercall quartzite? Well, the Ercall quartzite is a sedimentary rock, it's not a metamorphic rock, and it's better described as a quartz-aragonite rather than a proper quartzite. Now, it goes from being a very coarse-grained, pretty much a fused conglomerate formation as it is at the unconformity, and as you go eastwards it becomes progressively finer grained until it leads into the Comley sandstone formation. Now, for multiple grain sizes included eroded material from the volcanic formations from the late Precambrian that you find in Shropshire, and these are deposited, as I said, in parts of the conglomerate and into the sandstones. And what kind of environment was it? Well, it was a shallow marine environment, almost a beach level environment. We know this from the nature of the sandstone deposits and the eroded material, but also from one nice little feature that you'll find here at the quarry. So what we've got behind me is that little feature, and it is a series of ripples. It's easier to see after it's rained, but what we've got is this series of ripples from a shallow water environment very near a beach, and it's just part of that evidence that shows what this environment used to be like about 526 million years ago at the early Cambrian period in Shropshire.